Good morning, class 9th. We have started with exercise 13.7 based on the volume of a right circular cone. We have done the first 4 questions. Let us do the remaining questions. The exercise is on page number 233 of your textbook. Let's take a look at 5th question. A conical pit of top diameter 3.5 meters is 12 meters deep. What is its capacity in kiloliters? So there is a conical pit. Let's say this is the center. The top diameter is 3.5 meters and its depth will be measured vertically. So this is given as 12 meters. So according to this, what we have, the diameter is 3.5 meters. Using this, we can find out the radius, half of the diameter. So this will be half 35 by 10, dividing by 5. Radius is 7 by 4 meters, and the height, the depth implies the height is 12 meters. You have to find out the capacity of the pit. Capacity is given by the volume, and the volume of a conical object is given by 1 by 3 pi r square h. Let's use the values, find out the answer. Cancelling the terms with common factors. So this is 77 by 2 meter cube. 77 by 2 meter cube. You have been asked to express the capacity in kiloliters. Now what we know, 1 meter cube equals to 1000 liters. The number 1000 itself is 1 kilo. So 1 meter cube is equal to 1 kiloliters. So without any multiplication or division by some number, this is directly converted into kiloliters. If you want, you can change this to a decimal number. This will be 38.5 kiloliters. That's your answer for question number 5. Let's look at question number 6 of the exercise. The volume of a right circular cone is 9856 centimeter cube. You've been given the volume of a cone. The diameter of the base is 28 centimeters. Diameter of the base is given, so that means we have the radius as well. You have to find out first the height of the cone, second the slant height of the cone, then third curved surface area of the cone. So you've been actually given step by step indications to reach the third part. So using the things given, volume and diameter, we will find out the height. Then using height and the radius, we will find out the slant height using Pythagoras theorem. And finally, once we have the slant height, we can apply the formula for the curved surface area of a cone, which is pi r L. Let's write the answer. So this is what's given. Volume equals to 9856 cubic centimeters. The base diameter is 28 centimeters. From the base diameter, we can find out the radius. It will be diameter divided by 2. So this is 14 centimeters. Now the formula for the volume of a cone. This is for a cone. So the formula is 1 by 3 pi r square h. The value is 9856. Now let us use the radius from here. 1 by 3 pi 22 by 7. Radius squared, so 14 squared will be 14 into 14. Height not given, let it be as such. Now solve this equation to find out h. Simplify. Use the divisibility rules to simplify. So h is 48 centimeters. This is the first part of your question. Now let us do the second part. In the second part, you have been asked to find out the slant height of the cone. To find out the slant height, L, we will be using the Pythagoras theorem. L square equals to h square plus r square. Be very careful, the slant height is the hypotenuse. So hypotenuse square equals to perpendicular square plus the base square. L square, we don't have the value of L. Height is 48. The radius is 14. So L will be square root of 2500. This will be 50 centimeters. So this is the slant height of the cone. Now we have to find out the curved surface area of the cone. Let's find out the curved surface area of cone, which is given by pi r L, 22 by 7 into the radius is 14, slant height is 50. Simplifying, so 2200 square centimeter is the curved surface area. Now in case the question is directly the curved surface area, then you would have to do these first and the second parts yourself. If the volume and the diameter are given, if the volume and the diameter are given and you have to find out the curved surface area, you would know that you need to find out the slant height. To find out the slant height, what you're going to do is using the volume and diameter. Use the volume and diameter. Find h, because volume uses r and h. So r is given. Use r to find h. Once you have r and h, then you can use RH to find L, and then use R and L to find curved surface area. So in case first and second part are not given, you have to remember this for yourself. Let us take a look at question number 7 now. A right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. For this question, I would like you to refer to figure 13.13 on page number 218 of your textbook. In this figure, they have explained how a solid is formed when a right triangle is revolved about one of its sides, and the solid formed in that case is a cone. So in this question number 7th as well as question number 8th, they are referring to a right triangle being rotated about one of its sides. So when a right triangle is rotated about one of its sides, a cone is formed. Let us draw and see how the cone will be formed. So let us say this is the right triangle given to us. The sides are 5, 12 and 13 centimeters. They are saying that the triangle is rotated about the side 12 centimeters. So when the triangle is rotated about this side, the side which measures 12 centimeters, this side becomes the axis. You can think about the movement of earth, the way the earth spins on its axis. So the triangle will spin around this side. So this side will be still and the triangle will spin around this side. And when the triangle spins around, it will form a cone. This point here moves on this boundary in a circular path, and this becomes the base of the cone, and this here becomes the slant height, and the axis becomes the vertical height. So what we will obtain from here, the height will be 12 centimeters. You can write down cone is formed when a right triangle is rotated about one of its sides. Cone is formed, the solid. And for cone, we have 3 parameters: height, the vertical height, its base radius and its slant height, and we can obtain these three values from the triangle here. The vertical height is the height of the axis about which the triangle is spinning. The radius is the measurement of the side of the triangle which is on the base. This is 5 centimeters. Then the slant height is the hypotenuse. Now using these values we can find out the volume of this solid. So the volume of cone is given by 1/3 pi r square h. Using the values, radius squared, height, simplify. So this comes out to be 2200 by 7 centimeter cube. Applying the formula of the volume is easy once you have the values for the radius and the height. The important part here is to identify these values. How you recognize the height, the radius and the slant height for the cone. Then application is very easy. Now let us look at question number 8. If the triangle ABC in question number 7th, the same triangle here as given here, this triangle is revolved about the side 5 centimeters, then find the volume of the solid so obtained. Also find the ratio of the volumes of the two solids obtained in question number 7 and question number 8. Now you know that when a right triangle is revolved or rotated about one of its sides, a cone is formed. In this question, the triangle was to be rotated about the side 12 centimeters. So the triangle spins around this side 12 centimeters. In question number 8, the same triangle will spin around this side, the side which measures 5 centimeters. So I'm going to draw the triangle a little differently. I want to represent the axis. Axis is the side about which the triangle will spin. So I'm going to represent this as the perpendicular. So representing 5 centimeters as the perpendicular, 12 centimeters will become the base. The hypotenuse is still 13 centimeters. Now the triangle is spinning around this side. So this side will remain still and the triangle will spin around this vertical side, and hence again this will move and a cone will be formed. And in this cone you can identify the parameters. Solid formed is cone, and for cone we want the height, the radius and the slant height. So height is given by the axis about which the triangle spins. So the triangle is spinning around this vertical side. This will be 5 centimeters. Radius is the side on the base of the triangle due to which the circle is formed. Then slant height is the hypotenuse. Now you can find out the volume. Once you have the volume for the cone formed in this case, you have to find out the ratio of the volume obtained in 7th question and the volume obtained in 8th question. Let's find out the volume. 1/3 pi r square h, using the values. Now the radius is 12 squared, so 12 into 12. Height is 5, simplifying. So this comes out to be 5280 by 7 centimeter cube. Now we have to find out the ratio of this volume with this volume. So required ratio. For the ratio, I am using the expressions before simplification. So volume in question number 7 is 2. Volume in question number 8 without simplification. So this was 1/3 pi r square h. So I'm using it from question number 7th. So from question number 7th, without this cutting, before the cutting, So before the cutting, what did I have? I had 1 by 3 pi into 5 square into 12. This is what I had before the cutting. Now for the volume in question number 8, before this cutting, I have 1 by 3 pi into radius square. The radius is 12, height is 5. From here 1 by 3 pi and 1 by 3 pi, they get cancelled. Let's simplify the remaining part. We are left with 5 square into 12 is to 12 square into 5. So I'm writing this as a fraction, along with I'm expanding the squares. So 12 cancels, 5 cancels, I'm left with 5 by 12. Hence the ratio is 5 is to 12. And this is the answer for question number 8. Let us look at question number 9 now. A heap of wheat is in the form of a cone whose diameter is 10.5 meters and height is 3 meters. Find its volume. The heap is to be covered by canvas to protect it from rain. Find the area of the canvas required. So the question has two parts. The first part, you have to find out the volume of the conical shape which is formed by the heap of wheat. And in the second part, if you want to cover that heap, the conical heap, with canvas, you have to find out how much canvas is required. So first part is easy, finding the volume. You can use the diameter to obtain the radius. Height is given, so 1 by 3 pi r square h will give you the volume. For the second part though, to find out the area of the canvas required, we need to find out the curved surface area. For the curved surface area, you need radius and slant height. You have the radius because of the diameter, but you don't have the slant height. So you'll have to find out the slant height, and then you will apply the formula to find out the curved surface area of the conical heap. So this is given to me. Base diameter is 10.5 meters. The height is 3 meters. From the base diameter, I can find out the radius. This will be half of 10.5. Simplifying, converting the decimal number into a fraction, dividing by 5. This is 21 by 4 meters. I'll be using the fractional value to find out the volume. The height is 3 meters. So the value of h is 3 meters. From here, the volume can be calculated 1 by 3 into pi r square h. Let's substitute the values. Radius squared, so radius into radius. Height is 3. Let's simplify. These get cancelled. This also gets cancelled. So I get 33 into 21 by 8. So this comes out to be 693 by 8 meter cube. If you want, you can convert it into decimals. If you convert this into a decimal number, this is what you get, 86.625 meter cube. It is completely fine if you leave the answer in fractions. Now for the second part, we need to find out the slant height. Let us find out the slant height of the conical heap and then find out the area of the canvas required to cover the heap. For calculating the slant height, we have L square equals to h square plus r square, using the values of height and radius. Height is 3, the radius is 21 by 4 square. Now I'm going to convert this into a decimal number to simplify this, because later on I have to find out the square root. So this will be, so 9 plus 27.5625 comes out to be 36.5625. So L will be equal to the square root of 36.5625, and this approximately comes out to be 6.05 meters. Using this, let us find out the area of canvas required. the area of canvas required will be given by the curved surface area. This will be pi r L. This will be equal to, the radius is 21/4 into, the slant height is 6.05. Simplifying, this will be 33 into 6.05/2. So again, if you want, you can give the answer in fractions, or you can simplify to obtain the answer in a decimal form. So this will be 199.65 divided by 2. So this approximately will be 99.825. This is exactly 99.825 because you can divide by 2 completely. So this will be in meter square. So this is the area of the canvas required to cover the conical heap. And with this question, our exercise 13.7 is complete. The next exercise that we are going to do is exercise 13.8, which is based on the volume of sphere and hemisphere.